Hey folks, welcome to another episode of ASP.NET Core from Zero to Overkill. In this episode, we'll get started with Docker. So in the previous episodes, if you remember, we checked out the identity server, integrated all of our applications, the authentication service, the group management API, the backend for frontend, and the single page application, all working together with authentication and all that stuff. But while doing so, every time we wanted to get everything working together, we need to go to each applications, get it started, and that's a bit annoying if we just want to see everything work together. So for that reason, we'll take a look at Docker. Docker is important for a lot of different reasons, but probably would be a subject I was expecting to talk about a bit later in the series, but given it's useful right now, we'll just talk about it. And it's a popular topic, so it's not a waste of time. So in this episode and in the next one, but particularly in this episode, we'll start by creating some Docker containers for our applications. I'll show you some preliminary adjustments I did to the code base in preparation for this. Then we'll see how to containerize an ASP.NET Core application. We have 3 of them, but we'll only do one. The others will be exactly the same. And we'll containerize the Vue.js single page application. So in this episode, we'll just put everything in containers. In the next one, we'll use Docker Compose to, with a single command, get all containers running and have the application running with much less effort than now. So I'm not really going with an intro to Docker because there are a lot of better resources for that specific topic. I'll just show you how we can do it with the ASP.NET Core, and in this case also a single page application. But I would say, given how popular the topic is, even if you didn't heard about Docker at this point, it's easy to find good resources. And the usual plugs in these videos. So if the videos are being useful, please consider liking them, sharing, and leaving feedback, of course, because it helps improve. And if you want to see more stuff regarding these topics, check out my blog, and at Twitter I usually publish some stuff. Namely, when I publish on the blog, I warn everyone through Twitter. And with this, let's go. So I'm not going into much detail, but just as a quick intro, Docker is the most popular, but not the only one, of containerizing applications. And what does this mean? There's a lot of stuff in this topic, but for me as a developer, my favorite thing about containers is the ease of use and deployment. So we grab our ASP.NET Core application in this case, do some steps to create a container out of it, and then the deployment is really easy. The server which is targeted by the deployment doesn't even have to have .NET installed. It just needs to have Docker, and in that server we say Docker run group management API, and the container starts running, and we have it running without a lot of installation. So as a developer, that's for me what's more interesting. Of course, there's a lot of detail that I'm ignoring. For instance, containers are like more or less like a virtual machine in terms of isolation. So if a container goes down, it doesn't take the others down. So in that sense, it's kind of like a virtual machine, but lighter, because instead of having the whole operating system replicated, we have the containers share the kernel from the host operating system, and only need to have installed the things they need. And again, as a developer, this is really cool because And from what I was saying regarding installing software, for instance, if I want to run a Ruby application on my desktop, I don't need to install Ruby or a Golang or stuff like that. I just need Docker and can run it. That's why since the beginning, when we started working with databases, I didn't install Postgres. I just ran a Postgres container. So it's easier to start it, stop it, delete it, and instead of all those installations and stuff, particularly on Windows, where installation of software is a bit more annoying. So for me as a developer, that's the most important part. Operations and other members of the team will have other reasons to like it. So let's go to the topics. Let me just go here. So we'll start with some preliminary adjustments. Why is this? If you remember from when we developed stuff, particularly in the backend for frontend. Okay, I have opened the auth. I wanted to have open back for front. Close all of this. If you remember the startup, we had a lot of things hard-coded, so we had the path to the auth service here hard-coded, and even up here in the HTTP client, where is it? HTTP client, we had the base address hard-coded. Given we are putting this in Docker containers, this won't really work because we won't be communicating to localhost 5005. It will be different. So thinking about this, the easiest to do was to go to app settings, development, create these settings. So now the endpoints are here, and in the startup or other places we just get the configuration, in this case the API settings, down here auth service settings. So I created some objects here, so auth service settings, so it will work inside Docker, or better yet, these settings are for development, but then we can create settings for running in Docker or running in production or staging or whatever. But we won't need to change the code because it's already in settings. I didn't move everything. There are more things here that could be in the settings, in the JSON files or other resource, but right now, keeping it simple, this stays the same, and when we need to make another change, we'll just extract it and put in configuration files. Okay, so these are the preliminary adjustments. With those adjustments, let's go into the interesting topic of creating a container for an ASP.NET Core application. If we go back here to the sites, for instance, you can check out the ASP.NET Core documentation, and they have documentation about this, which is probably in more detail than what I will walk through. So, what is Docker? Automating deployment of applications. So, for more detail, I would recommend you take a look at here. So I'll be assuming you already know more or less what is Docker. And okay, so Docker images, talking about these, but I'm going to jump into creating these. So I have here the this is basically open on the folder for the here. So ASP.NET Core, all the repos are here. So I have Visual Studio Code open here because we'll need to create a couple of files. We'll use group management to make as our sample. The authentication service and the web front-end server would be exactly the same, so we're just gonna use one of them. So group management it is. And in Docker, a Dockerfile is what we use in Docker to describe how to build an image to be used later for a container. So a Docker image is like, I don't know, basically a Docker image is like when we define the class, and a Docker container is an instance of that class. So a container is, we grabbed an image and started something running based on that image. So the Dockerfile is how we describe how to build that image to have the necessary components. So the binaries, dependencies installed, all of that. So in Dockerfile is where we describe how to do that. So you can go to the docs as always. There's information. So how to create a Dockerfile, all the stuff. So this is the file reference. So there's all the commands we can use here. And the first command, I think it was over here or not. Where was it from? Wasn't it here? I don't know. Let me check. Okay, let's just get started. So the first line on the Dockerfile is from. Let me start by creating here. We create a new file, Dockerfile, and you see immediately it recognizes, and here's the Docker whale. So the first line in the Dockerfile starts with a from, and we have completion and all. So from is a base image, like it says in the docs. So we are basing on something. We can base on some Linux image, or we can base ourselves, or Windows. There are also Windows containers, although I think it's not the most popular. Most of the time are Linux containers. But we can base ourselves on such a container and install everything we need, or we can base ourselves on other images that already have the tools we need installed. In this case, we will create a Docker image for ASP.NET Core application, so we can check out if Microsoft already has a base image for that, which it has. If we go here, and there are multiple images. I will explain probably a bit later, but we'll start with an image that has the .NET Core SDK. Why is that? We have a couple of choices when creating the image. We could compile the application in our computer and then generate the image from those binaries already compiled, or we can build the application already inside the container. And that's because when we are developing, maybe that's not as important, but it's nice when we, for instance, have a build server. Instead of the build server needing to have, in this case, .NET Core SDK installed on the build server to build and then create the Docker image, it just needs Docker installed and Git to get the code from somewhere. So it gets the code and then can do Docker build the image, and the image itself, being based on .NET Core, can take care of building the application. There are also runtime images. So in this case, we can't build the application in here because it just has the runtime, doesn't have the SDK to build it. But these images are nice because they are smaller, because they have less things installed. We can take advantage of both of them, but I'll discuss that later. For now, just know that we are going to use a .NET Core SDK image because we want to build the code inside the container and not in our computer. So, if we want that, this tells us where to grab the image from. So, I'll copy this part. We'll go here to the back here and we say from this. This is the base image. If we do just like this or like this, latest, it'll grab the latest version of this. But if we check here, there are other tags. These are most important. So by saying this by saying latest, let me see down here. You see latest, we'll go to 22, so it's the same as in here. So we can have multiple tags that mean the same thing. So tags can be versions, for instance. As if we wanted to use the long time support version, we could say 2.1, or we can say latest or 2.2 and grab the latest one. In this case, 2.2. Another interesting thing is there are alternatives based on different operating systems, for instance. And normally, when it exists, I tend to go with an image based on Alpine Linux, because normally these images are smaller, so we can have more containers running in the same space. Maybe some ops person will tell me why I shouldn't do this in one or another reason, but we are just playing around and Alpine works well, so we're going with that. We're going to use an Alpine image, so we can use this 2.2 Alpine. Go here instead of latest, put this here. Now I'll give it for later, and just so you know, I'm not doing this by heart. I have notes on the other screen. If not, this would take a lot longer to build this image. So this tells us what's the base image that we want to use. Then I don't know if this is mandatory, probably not, but I always see people do this, so I follow the same, as I'm no specialist in this, and I create a working directory where we'll copy our files into. And now, the thing we need to do is copy all the files into our container. So currently the files are in the file system. If I go here, basically we are here. If you see here, there's the Dockerfile. So what we want is copy everything that's in here into there, so we can build the application. But even though we want to build the application, there's something interesting to talk about. So normally, if we wanted to copy everything, we would do copy dot, so something like this, to copy everything in the current folder to the current folder inside the container. So we see this is the current folder outside the image, and this is for the image that we are creating. In this case, it would be inside the app folder we created. The problem with this, and basically we would do this and then run .NET restore to restore our packages, and then we could publish the application. So for instance, let me grab I'll just copy these from my notes to be faster. So working directory would be inside app, source, and then our web application folder, and then we would run .NET publish, configuration is release, and we want to output into a folder named out, for instance, just because of reasons. Okay, so this would work. We would copy everything, .NET restore, then change the working directory to the web application, and then publish the application. This would work, but this has a problem. Each time we change a file in our application, for instance, we are each time we are coding and we change startup CS, add a line, or we change the app settings file. Every time we do this, when we want to build the image, it will have to do everything. So it will have to copy stuff and then .NET restore, because this is always in a new image. .NET restore will always have to download everything again, because when we are doing in our computer, if we do a change in .NET restore, it won't do anything because it has already restored. But when building the container, it doesn't have anything inside there yet. So it's like a clean slate. Every time we do build, it starts from scratch. So it will have to .NET restore the packages, and in a big application it will have a lot of packages, so it will be annoying. But Docker has a way of working in layers. So basically, every time we create an image, some parts are split into multiple layers. For instance, let's take an example. If I go here, grab this. We'll go here and do Docker pull this. This will probably not work because the image is already here. So let's try with this one. So if you see, these different hashes are different layers. So maybe one of these layers is a Linux part, and another is because it installed curl, and another is because it installed another tool. So it has multiple layers that can be reused across images. And why is that important to us? Let me stop this because I don't want this image. But why is this important to us? Because we can take advantage of those layers to cache parts of our image. So there are some commands in Docker. For instance, copy is one of them, run is another one, and there are others. I don't know them all, but these are what are relevant for now. Creates a layer every time we use it. So what we can do is, and I'll just copy this from the notes to avoid being here for a long time. Instead of copying everything immediately, we can copy, for instance, the CSproj files, keeping the same folder structure, and then do .NET restore only with the CSproj. Why? So if we change CS files, so the startup class, another class, as long as the CSproj files aren't changed, .NET restore doesn't need to run again, because when we get here, it will see, oh, those previous layers are exactly the same, so I don't need to do anything with this layer, because assuming it's deterministic, unless we put some random stuff on the layer, but assuming it's deterministic, if all the other layers before are the same, then this is the same. So if we copy the files and the output is exactly the same, .NET restore doesn't need to run, because we already have a layer with that information. And that's why it's a good practice to do this. So I'll copy this, the other parts. So I'm doing this for all the CS project files we have, and this is the worst example I could have because group management is the only one with a lot of libraries yet. Probably there's a better way to do this instead of copying everything one by one, but I haven't invested much time in that. This works, I don't care. Another thing, of course, we copy the solution file. So copy the solution file, and then when we restore, we are in the folder of the solution, which knows where are the various CS project files because the relative path was kept the same. So as long as we don't change dependencies, these layers will be reused across building the images. Okay, so with this trick done, so we copy all the project files in this solution, .NET restore, we cache Docker automatically caches the layers, and now with the restore done, we can do the rest. So we can copy everything. The work dir is this one, and we publish the application to there. And now I'll talk about the thing I mentioned in the beginning. So we're using the Sdk image. Let me show you. Docker image ls. So this is the Docker Sdk image. Alpine, it takes almost 1.5 gigabytes. The ASP.NET runtime image, also Alpine, takes 168 megabytes. So this is a lot of space because of the SDK that we don't need because we are running an ASP.NET application, so we could use this image. But how can we use them? If we use them, if we chose in here and we need the SDK to build. So Docker has a neat feature. I would say recent, but no, it's when I first learned Docker it didn't exist, but now it exists, which is the multi-stage builds. So what this means is anytime we do a from, we are creating a new stage, and we can use different images in different stages to do different things. So we can go here, give it a name, and down here I can do from, and I want another image. So this was the SDK, this is the runtime. I put it here, I want Alpine, because small. It's just an example, let me check. I'll do this here. Docker pull, and it'll download just for us to compare, and we'll give it a name even though we're not going to use it. We give names so we can reference the other stages from another stage. So in this runtime stage, we'll be able to go to the builder stage. Let's check if it downloaded. It did. Let's see the images, and we have ASP.NET, the 2.2 and the 2.2 Alpine. And this is the reason why I want to use Alpine. The Alpine version is 168 megabytes and the other is 260. So 100 megabytes less, it's really good. I think it's worth it, and it's not more work. So maybe there are some incompatibilities, but don't know. Using it to play around like this, never had any issue. Okay, so let's go back here. So we built the application here in this builder stage. Now we can go into this new stage in which we are actually building the output container image. So this was basically is like an image just for building, and now we are going to have an image for actually running the application. So we'll do the same, work dir application, and what we'll do is copy from stage builder. We even have autocomplete, awesome. And then we say app slash source slash group management web stuff slash out, which was the output we set for the publish, and we copy to the current folder, which is app. With the binaries already here, we can create an entry point. We say the executable, and the executable is .NET. So it's the we have in this image, which is the runtime, we have access to .NET, and then we can pass arguments. And in this case, we want to pass in .dll, because if you remember, if we go to source group management web cd bin debug do ls, and we have the DLL, which is what is ran by .NET. No, not this one, this one. Sorry. So the web DLL, it's the entry point of our application. When we do .NET run, that's what is run. We don't need to say the name because we are in the folder with the CS proj, but if we weren't, we would need to do .NET image playball group management web DLL, and this should run. Of course it blows up because we are not in the good place, but sorry, group management. Okay, back here. Okay, so the entry point says we need to, it's everything. So, and the final image will be small or smallish. Other tech, I think in .NET Core 3.0 the containers will be smaller, right? But which is nice. Right now it's like this, but it won't be that big because we are not using the SDK, we are using the ASP.NET runtime. Okay, so the Dockerfile is ready. We can just use it. So in here we can build the application. So to build the image, we use docker build. Then we say -t, which is tag. The name is not great because it says tag, but this is the way we give it a name and a tag. So the name isn't great, but okay. Sorry. And we'll call it coding militia / group management. We can give it a tag like latest or not. Yeah, no need. And then we say where. We can say, or better yet, we can say the Dockerfile. In this case, the Dockerfile is in this folder, so we just dot, and it will create the image. So it goes. This is faster because I already have the images downloaded. If not, it would download them automatically. So it copied everything. It is running .NET Restore. removing, see here, removing intermediate container is because it removed the, I would say, the container with the other things, the container that was running to build the application. And then runtime, blah blah blah, copy everything, and it's done. Okay, so this is the annoying part because this is Windows, then warnings because of permissions and stuff. So yeah, I'm not worried right now, but would probably be worried in a production environment. But probably production environment, we wouldn't build the containers ourselves. It would be a build machine specific, so no need. So now if we do docker ps, or better yet docker images, ls, we now have group management with a total of 171 megabytes. And we have this one with no name. So this is the image that is used with the SDK. So it's here cached. And I don't know how to see the layers, but if we wanted, we could see the layers. But okay, so we have a container, it was built. We can try to run it. It won't run, but we can try. It won't run because the other dependencies are not ready. We don't have the correct ASP.NET Core environment variable. We don't have the Postgres database, but we can try to run it anyways. So we can do coding group management, give it a name, call it group management, and -d, which is for detached. If we don't put -d, we'll see the application running and the logs. If we put -d, it will, okay, I put it in the wrong place. The name group management, and the container will be militia group management. Okay, so instead of showing me the logs, which is what this is, it just gave me the ID of the container. If we do docker ps, there's nothing there. Okay, it's Postgres. But if we do docker ps a for all, we'll see that this is the first one that we ran. So docker rm, and I'll remove that one. But if we do it again, so this wasn't what we ran, so the name is group management, and it stopped immediately because, like I said, things are not working. Here are the logs. If you want to see the logs or the latest things that the application wrote to the standard output, we can do docker logs group management. So it's the name of the container, not the image, the container. And we see this. So it was an exception because it doesn't have the connection string. And why doesn't it have the connection string? Because we didn't pass the environment variable indicating what environment should the application run. So it assumed production, and we don't have an app settings file for production. So that's why it blew up like this. But okay, we aren't going to put this running right now because we need everything done to get it to run. So that's a topic for the next episode. In this episode, we'll just build the containers. So we just built the image for the ASP.NET Core application. So this part's done. Like I said, authentication service and the backend for front ends will be exactly the same, so no need. But now we'll check out how to containerize the Vue.js single page application. So let's look at that one. We can close this one. We'll then go to web frontend, client, and we'll create a Dockerfile. So I'll go through this faster because it's exactly the same principles, just applied to a different tech stack. So in this case, from we'll use exactly the same strategy. So we'll use a builder stage. So we build our Vue.js application using Node, and it will generate static assets that we'll need to serve. We have several options to serve. We could generate the static files, the HTML, JS, CSS, and put it in, for instance, the BFF container, or we can use something specific to host it. That's the strategy I'll go with, so we can keep the containers for the different components of the application separated. So we'll build the application first with an image based on Node, and then we'll use an image based on Nginx, the web server, which we'll use to serve the static files from the single page application. So I'll start with from Node LTS autocomplete, nice. Node LTS Alpine as builder. Then the same work dir app. And now the same strategy, what we did for the CS proj, we can do here. So we copy the package JSON files onto here, and then we run npm install. So exactly the same, just a different tag. We copy the package JSON onto the image, then run npm install. It can install all the Node modules, and we know that in case of Node this is even more important than with .NET, because there's a lot of packages and a lot of downloading going on. And now after doing this, we can copy everything and then run npm run build, which will build the application. And then again the same strategy from, in this case, Nginx Alpine. So now we can do, I'll just do this, probably not needed, but we'll remove everything that's in user share Nginx HTML. So this is the default Nginx file, and then we'll copy from stage from builder app dist, which is the output folder, and we'll copy it to user share Nginx HTML, and we're done. It's done because in the other case we need the entry point. Let me just put this in. In the other case, we need the entry point because we need to run the application. And in this case, the entry point will be the engine already defined in the Nginx base image. We just created this to put our static files in this. There's something missing, but let's just first look at this go. So let's go back, go to web front-end client. Hopefully it will work, because sometimes these Windows permissions and this node stuff can cause trouble, but let's see. So docker build militia / web front-end / spa here. Let's see if it works. So you want to start now? What about now? No? Oh, yay. npm install, let's see. Hopefully it will work. I was going to record this episode in Linux because it's easier to get this all running, but the recording wasn't going to be as good, so hopefully Windows doesn't fail me here. Seems to be working. Docker run stuff, yay, it worked. So now let's see, docker run detached name SPA, and now coding militia / web frontend / SPA. Yay! So this one should work, even though it will probably be a bit broken because we don't have the APIs and all of that. Let's see. So it should be localhost 80. Why doesn't it work? Nginx is there. Port 80. Oh, I forgot. It. Docker force SPA. So we need to expose the port. So we want port 80 on our host machine to be port 80 on the container. And now, what about now? Okay, so now it will be loading forever because there isn't we don't have the API running, but this is working. One thing you will note is if this worked, this would work normally, but if you go to groups, which is the route for our groups application, for our groups section, it says not found. That's why we need to do a slight change in the Nginx configuration, so that when it doesn't find anything, it will fall back to the index.html file. So the routing works. So in this case, what we need is to serve the index.html, and then it will see that the route is different, and JavaScript will do its thing and go to the correct place. But for that we need that fallback. So we need to complicate this just a little bit. What we'll do is to copy over here. Can do at any place. We need to copy a file which is nginx-conf, which I'll show you, to etc nginx conf d default conf. So I have an nginx conf file already prepared, you can see it here, and we'll copy it to default conf, so nginx will use it as the default configuration. And this is basically as the default configuration of nginx with one difference. So we are listening at port 80 the same, we use the same route for the static files. The location is basically the same, but we added this index.html. So if we make a request that nginx doesn't find, it will serve the index.html, making the routes work. So with this in place, we copy it there. Let's create this again, remove the running one, we'll build it again. This should be faster this time because cached layers and stuff. Come on. Okay, let's run it. And now we should see something, even though weirdly. So now it groups. This is very strange, but basically what's happening, it's even the API requests are being served as index.html. If we see here, let's see the network. If we go here, so the request to the API info, it gets a response, which is the HTML. So it's working kind of stupid, kind of broken, but it will be solved when we get everything working and the requests go to the API instead of going to nginx. But that's a topic for the next episode. So in this one, we saw some adjustments, then we containerized an ASP.NET Core application, and now we did the same with Vue.js application. In the next one, we'll get it all working together in with a single command. We will be able to get playball running. Hopefully you enjoyed it and it was interesting. Please don't forget to provide feedback and sharing if you thought it was nice. Hope to see you in the next one. See yous!